Hi, this is Mrs. Yamamoto, and today we're going to be talking about segment proofs. And we have right here a handout of references of the different reasons we give for our statements in our two-column proof. So first at the top we have properties of equality. We've already gone over the properties of equality. Keep in mind though that the properties above may be used with only equal signs. We're going to talk about properties of congruence. So the properties of congruence can be applied to statements with congruent symbols. The reflexive property of congruence states that for any segment A, B, essentially, AB is congruent to itself. The symmetric property of congruence states that if we have a segment AB and it's congruent to segment CD, then that means that segment CD is also congruent to segment AB. The transitive property of congruence states that if segment AB is congruent to segment CD and segment CD is congruent to segment EF, then we can conclude that segment AB is congruent to segment EF. Next, we're going to look at some definitions. Definitions are also reasons for our statements in our two-column proof. We have two definitions that we're going to talk about, the definition of congruence and the definition of a midpoint. So segments are congruent if and only if they have the same measure. So for my first statement here, I have a conditional statement. If AB is congruent to CD, then the measure of AB is equal to the measure of CD. And the converse of that would be true as well. If the measure of AB is equal to the measure of CD, then AB is congruent to CD. Moving on to the definition of midpoint. So the midpoint of a segment divides a segment into two equal or congruent parts. So if M is the midpoint of AB, then AM is equal to MB. So just a quick visual here. If you had AB and M was the midpoint, then AM is congruent to MB, and it divides that segment into two equal or congruent parts. Last thing on this side is postulates. So this is one postulate that we're going to talk about, and it's called the segment addition postulate. The segment addition postulate states that if A, B, and C are collinear points, so A, B, and C are collinear, they're on the same line, and B is between A and C, so point B is between A and C, then we can conclude that AB plus BC is equal to AC. So not necessarily that B is a midpoint, but the segment addition postulate just states that if A, B, and C, 3 points are collinear, and B is between A and C, then AB plus BC equals AC. So let's go ahead and practice the following questions by justifying each of the following statements using a property of equality, property of congruence, definition, or postulate. Starting with number 1, if PQ equals PQ, then PQ is congruent to PQ. This statement can be justified using a definition of congruence. So I'm going to write here on number 1, that the justification for Number 1 is by the definition of congruence. So here on this page for 1 through 12, use the property bank below here and choose from your properties of equality, properties of congruence, definitions, and our postulate. And write that justification on the line right over here. And this is practice so that when we do get to our 2-column proofs, where we will be given information about a midpoint or segments or intersecting lines, we can use the reasons that we have here in our property bank to justify our statements and complete our 2-column proofs.